Hey, welcome to our little fireside chat. We're going to talk about stunt design real quickly today. And one of the winningest airplanes in stunt history is the Nobler. And we're going to talk about why I think it works so well and how you can design your own airplane. A lot of people have asked me, what do you have to do to design an airplane? Well, you just copy. Simple as that. And most airplanes today are this airplane here. So this is the physical specimen here of the Nobler. And you ask, what makes this airplane work so well? Well, it's in the numbers. The nose only has to be long enough to balance the tail. So if you build real light, you can have a short nose. And the more the airplane weighs, the more tail heavy it is. So you have to lengthen the nose. Now let's talk about what does lengthen the nose do for you. Well, it sets up a thing called clock time. The longer you make the nose, the more time it takes to go around the corner. And the more nose heavy the airplane's going to feel. You have a solid piece of steel, in this case aluminum and steel, out there on the nose, a foot away, actually more than that, from the center of gravity, because the center of gravity is measured from this part of the wing right there. Right there is where the center of gravity is. So we have the distance from here all the way to the nose. So if you have a 10-inch nose, but it's 3 inches back, the center of gravity, the actual number is 13. Now you're all spinning out about what is all this numbers and stuff. I work on the TLAR method. And that TLAR method is that looks about right. I'm not real good with math, like some of the guys, pi r squared, radius 20, around the corner, whatever. That doesn't mean anything to me. If it looks right, it's going to be right. Where my experience comes from is I've built a lot of airplanes. So after building a lot of airplanes, you know that the more chord you have in the wing, the more clock time you add. The longer the nose you have on that, it exponentiates even farther. So now we have all this in the nose, we have to lengthen the tail. So it's all about time. And what this really all bases on, it's all about weight. So you say, well, why do you say that? Well, the lighter you can make your airplane, the longer you can make your airplane without overpowering itself. There was a time I heard that the reason the 4-inch bell crank came into effect was they were worried about power steering or oversteer or whatever. Well, if they just took the weight out of the nose, the airplane would have turned faster. Instead of trying to lever the airplane around the corner with bigger bell cranks and wider controls and all that other stuff. So now let's talk about flap size. A lot of guys like big flaps. Well, you have to have big flaps if your airplane weighs a lot. If it doesn't weigh a lot, you don't need much flap. As a matter of fact, it's a detriment because the more flap you put into the airplane, as you give it control on a light airplane, it acts as an air brake. So the airplane actually stops in midair and then goes around the corner. So you want to fly, in my opinion, you want to fly off the tail. But I got to tell you, as a prerequisite, I've never won the Nats. I haven't been in the top 20 or anything like that. But as far as building airplanes, hey, I'm not afraid to build against anybody. The flying part is all about practice, and I just don't have the time to practice. But I like to build, so I'm passing on a few of my building things. So let's go back to design. So here we have the perfect uh, winningest design, the nobler. And I don't know, there's going to be some disputes about that. Everybody's got their own opinion, but let's just take the nobler. Heck, if you like the imitation, or if you like the impact, if you like the thunderbolt, if you like whatever, it doesn't matter. The principle still works the same. Take the airplane and put a different dress on it. You don't like where the canopy sits? Move it forward. You don't like where, if you don't like that, move it back. If you don't like the shape of the rudder, change it. If you don't like the shape of the tips, you can change those too. There's nothing holding you back. So let's talk about how I come up with just off the wall design airplane. Well, there's no set of plans, no predetermined shapes. There's nothing. If you guys remember back, I built the MC-72 on electric airplane on the forum, and all I did was is I went on the internet and I saw an airplane that I liked the design of, which was the MC-72 profile. So just basically what we're looking at here, only it was the MC-72. That's Machi Castoli. And I said, well, we'll build one of those. So I took the profile of that airplane and I blew it up to the size that I wanted it down at Kinko's and overlaid it on a set of plans and found that, well, this is where instead of the wing actually being set here where it would be on the plans, it's actually set up here. So you just move the wing. So basically you have a template here that you can make any airplane out of. So let's say that, like I said, you like the Thunderbolt, or you like the imitation, or you like Thunder Gazer or whatever. Go on the internet, find you a picture of an airplane that you really like. You like the profile. Try to get a 3-view or 3D drawing of the airplane. Go to Kinko's. Measure on your plans that you like, let's say the imitation or Thunder Gazer or Thunderbolt or whatever, and say, well, the fuselage has to be this long. So go to Kinko's and say, I'd like this this picture or this set of 3-views blown up to this size. So they'll blow it up and overlay it on top of your already existing set of plans, and that's where the wing goes. Okay, great. So now let's talk about straight wing, taper wing, elliptical wing, all that business. They all work the same. It doesn't matter. You can see winning designs in everything. We had a guy in Lafayette Escadrille, John Garrett, who could take a twister, a box stock SIG twister, and beat you with it. It's all about his practice. That's what he did. He just stayed out there and flew thousands and thousands and thousands of flights. Used to drive me crazy. How in the heck can this guy fly this crappy twister? But 20 years he had it, and he flew it every day, and he was good with it. So it doesn't matter. Anyway, they all work the same, in my opinion. And we're going to talk about certain features of the Nobler. You'll notice that the Nobler here has a turtle deck. What do you guys think the turtle deck is for? That turtle deck is a weather vane. If you look at the top of a barn, you'll see a chicken or a rooster or whatever sitting on the barn, and behind it he has a tail feather, and wherever the wind's blowing, that tail feather is pointing the nose. So if you're downwind and you have a weather vane effect or more side area behind the center of gravity, it's going to push the airplane out, in theory. It's kind of like when Alan Brickhouse told me, so, well, I take off uphill or upwind. Well, some guys do, some guys don't. Some guys take off into the wind, or whatever makes you happy. But his theory behind that was that the wind hit the side area of the fuselage and pointed the nose out as it rolled around. And it actually is a good way to do it. I take off wherever. It doesn't much matter to me. That's probably why I'm not a champion or whatever. But as the wind is blowing the nose out, you're coming around, and by the time you're at a quarter lap, you're going downwind. I don't particularly like downwind because the wind catches the tail and blows the nose up, and you nose over and chip a prop, and props are just too expensive. Anyway, back to design. So how I come up with a good size stabilizer of the wing, opposed to the wing, is by the wood that's available. Most wood comes to us in 3 or 4 inch sections, so we're going to build a stabilizer. So we have a 3 or 4 inch section. Now there's exceptions to the rule, so to speak, like this one. This one is built up, but this is 4 inches across here, and that's 4 inches across there. Not because I could have made it 8 inches. It doesn't much matter. But I used what I had, the existing wood. So that's the root of the elevator stabilizer. Let's say 4 inches or 3 inches. In this case, in an older case, it's around 2 3/4 because it can be cut out of a 3-inch sheet. So then I take, for the span of my elevator stabilizer, I take the longest wing, which would be the inboard wing, and I measure from the back of the trailing edge to the center of the wing, and that's how long my stabilizer is. Is that right or wrong? I don't know. You have to ask Brett. You have to ask Paul. You have to ask these guys that are aerospace engineers. This is just how I do it. Half the distance of the wing. So you got 3.5 at the root, and let's say, well, I really want a really sweepy looking elevator stabilizer, so I want 1.25 inches at the tip, or I want 2 inches at the tip. But I would suggest that you try to keep as much surface area on the stabilizer as possible. Not only that, it helps the airplane go around the corner. Anyway, on to the next thing. We've kind of covered quite a bit of ground here. So we have elevator size and my theory on flaps. We have the nose length and we have the tail length. So remember, you only want the nose long enough to balance the airplane. So if you build light, you don't need a long nose. If you have a Briggs and Stratton in the nose, you don't need a long nose. It only has to be long enough to balance the airplane. How do you figure that out? Well, I'm sure that there's some type of mathematical formula or whatever to figure that out, but I just do it by trial and error, and that looks about right, or whatever. We know that, let's say that the last airplane that I built had a 9-inch nose and had a PA-65 in it, and it was, the airplane weighed 70 ounces, and it was tail heavy. Well, I have 1 or 2 things that I can do. Not build a 70-ounce airplane. That's the first thing. And that would mean that it would balance by lightening the airframe up more. The new nose shifts forward because the greatest percentage of the center of gravity is behind the CG, so the higher the weight goes, the more the tail heavy it is. So you can either build it lighter or lengthen the nose. If you lengthen the nose, we're back into that clock time thing where you're flying along and it takes forever to go around the corner. My Geo XL is an odd entity of it turns sharp, but it has a long nose on it. But it also has 3/4 set back. The motor is moved back towards the center of gravity. So we have the appearance of a long nose, but the weight, the motor is moved behind, moved back 3/4 of an inch. Now, 3/4 of an inch doesn't sound like much, but it's a long ways when the airplane's only 58 ounces. If I were to make that airplane 65 ounces, first off, it probably wouldn't balance, but it would, I don't know, it would kill me. Anyway, so we're talking about, theory and design, and my best thought on for you guys is to build a lot of airplanes. Try different things. Well, if I lengthen this and shorten this, what happens? I know that sounds, it's kind of costly, and that's why I'm giving you a little insight on this. Now let's talk asymmetry. It all works. You can. There's been guys who have made mistakes and built the asymmetry where the outboard wing is longer than the inboard wing. They just add more tip weight out there, or they built them symmetrical, where they're both the same length, and they add the tip weight out there, or they built 3/4 of an inch, 1 inch, inch and a half, 2 inch, as in the case of the Nobler. I believe the inboard wing is substantially longer than the outboard wing. I don't know. I have to measure it. It's been so long since I built it or everything. And what this does is the longer inboard wing, you think, well, it's going to cause it to lean in. Well, no. The longer the inboard wing, the less wingtip weight you have to put on the outside. And you say, what do you mean the less? Because it creates lift. It's creating more lift to offset or compensate for the weight of the lines. There's a difference between using 18 thousandths and 14 thousandths lines. The 18 thousandths lines are heavier, meaning you have to add more tip weight. You say, well, this is around and around and around in a circle. There's a lot to know here. Exactly. There is a lot to know about this, and it's mostly, in my case, trial and error. I'm not an aerospace engineer or anything like that. I only know that, well, I tried this and it didn't work, so we'll try this and maybe it'll work. So it'll all work. A toilet seat will fly if you put enough horsepower to it. A brick will fly. As living proof, all you have to do is look at the F4 Phantom, because it has the glide ratio of a brick. If the engines are off, it's crashing. That's terrible. So it's all an experiment. It's all about what you want to do. Have fun with it. Take your set of plans that you like, the Nobler, whatever, it doesn't matter. Go to the internet, find an airplane that, oh, I really like the looks of that airplane, it's sweet looking. I would suggest that you fly the airplane that you're going to build before you build it. And you say, well, what do you mean? Well, just because you like the imitation, Nobler, Pisces, SV11. SV11 is a good platform to build from. The perfect example of the mannequin having a new dress is Vic Macaluso F-14. Now, is it scale? No. It just gives the impression of being an F-14, and all that was an SV11. So he changed the looks of his SV11 to look like an F-14. And this illusion, Al Rabe is perfect of the illusion of scale by his detail and paintwork and masking and weathering and all that nonsense. Is the airplane scale? No. But when you look at it, you go, well, hey, that looks like that. But who's going to get the tape measure out and measure? Well, is this pi times radius squared the same distance as this? It doesn't matter, as long as you like it and you like the way it flies. Now, the SV11 is a perfect platform that I myself have built many airplanes off of. Take an SV-11, chop off the wing tips, put round tips on it, change the turtle deck, because the SV-11 is a big nobler. If you look at it, it's got a turtle deck, and the Magnum, Sig Magnum is a big nobler. There's nothing new. So take your SV-11, dress it up any way you like, paint it any way you like, and there's your design. So here we are. We've come full circle on that. Why try to reinvent the wheel? Somebody else already did the work for you. Hey, there ain't nothing wrong with stealing the idea. So, go in there and, hey, it's about what you like to do. So, as I said, they call it semi-scale. Some call it cartoon scale. These are lawn darts because there's no. I guess this airplane was designed off the same airplane that I think it's Frank McMillan. Yeah, Frank McMillan, his Calderon. This is supposed to be a some type of air racer, and that was the thing of the past. But the Tucker Special was supposed to be a S6B Supermarine. Those airplanes are a little hard to design around because, hey, they were supposed to have floats on it. Unless you fly off the water, a little hard to have floats on it to make it recognizable. But by paint and manipulation of the numbers, you get an idea what it is, and who cares? So have fun with the design. It's really simple. There's nothing. Don't try to reinvent the wheel. I use a shoe. I showed that on a couple of videos on airfoils. After building many airplanes, you'll know that you want a 10-inch cord or you want an 11-inch cord, and you want the center of pressure 3 inches back or 3.5 inches back, whatever. You draw a line. You take your shoe, you go from the leading edge to the high point of the wing, and then follow that curve on over to the trailing edge. And you cut it out and you go, well, I just designed this rib, and you lay it on top of an SV-11 rib. It'd be the same thing within a pencil line. It doesn't matter. The Giske Nobler was this airplane with, he drew the rib patterns 1 pencil width thicker. What does a thicker wing mean? It means that the airplane can weigh more. And there's a funny thing about that too, about the scaling effect that I haven't been able to figure out. Lou McFarlane back in the 60s come out with a Shark 45, and we were down at Whittier and Arrows and we were talking, wow, God, this is the death of stunt. It's terrible. The scaling effect was awful. The more you could just about tell what an airplane's going to weigh by the wingspan and the thickness of the wing. And unless the guy is really good, like Billy, with wood selection and paint being very stingy with paint, it's going to be about 1 ounce per inch. And you say, well, what's that mean? I don't know whether it's the volume or if it's a 60-inch wingspan, it's going to be at least 60 ounces. And it's just hard to get them under that. Perfect example is my June RXL. It has a 58-inch wingspan. It weighs 58 ounces. How does that happen? Most of them outweigh that. It's kind of like the 1 horsepower per cubic inch rule, I think, where if you can get a 327 Chevy with 327 horsepower, 1 horsepower per cubic inch, you're just about on the upper edge, unless you got deep pockets and want to spend buku bucks to make 500 horsepower. It's 1 horsepower. Harley Davidson, same way. 95 cubic inch going to have 95 horsepower. 103 inch, you're going to have around 103 horsepower. it's kind of like a basic rule of thumb, I guess. I don't know. But anyway, the Nobler has a 50-inch wingspan, and most of them weighed 50 ounces, and they didn't fly worth a crap at 50 ounces. But that's just the way it was. You got this one here is 38 right now, and to put the clear on, it'll be around 42. And I'm in Dayton, and so we're going to take it over and finish it up at my buddy's house, and maybe fly it next season and bring it out. And I'll probably end up giving it away or whatever. Anyway, thanks for watching me ramble. Till we see you again, fair winds, tight lines. If you have a question, leave it in the comment section, ask me on the forum, call me on the phone, whatever. Hey, be sure to check out my t-shirt shop on Teespring. I have this design, I have the Schulte's artwork, and not only that, it helps the channel. And till I see you again, fair winds, tight lines. See ya!